Extension cords are an everyday item used to extend power from an outlet to where it is needed. In this video, we're going to repair a damaged extension cord end, look at the reason it failed to begin with, and discuss situations in which you would not want to repair an extension cord. Hey, my name is Dustin. I'm a licensed master electrician. Welcome to this episode of Smarter Sparky. This cord is relatively new, so let's start by addressing what actually happened to it. The receptacle end of this extension cord is melted. Now, this is in no way the most extreme example of a melted cord end, but it is melted nonetheless, making it very difficult to plug anything else into it. Intuition would say that this cord was overloaded, right? That's not the case at all. So what exactly happened? To answer that, we need to go out to the workshop. This is my tractor. I mostly use it for snow removal in the winter, and it lives outside in an unheated shed. I just brought it in here in the heated shop for this video. When it's really cold outside, I like to use the block heater to preheat the coolant and make the engine a little bit easier to start. And this is the extension cord I've been using for the last few years to do that. Now, this block heater only pulls 10 amps. And this is 14 gauge copper extension cord, which is good for 15 amps. So I was nowhere near overloading this extension cord. So why did it fail? The reason it failed is because the plug end on the block heater became tarnished and corroded. When plugged in, the block heater starts to pull current. The corrosion on the plug end acts as a resistance in the connection, and Ohm's law tells us anytime current flows through a resistance, we get heat. Basically, the plug end started to act like a heater. The heat then propagated to the extension cord end, causing it to start to melt. To fix this, I'm going to replace both the extension cord end as well as the block heater end. There are all sorts of cord ends available on the market. As long as they are rated for the current and voltage that they're to be used with, and they are listed by a nationally recognized testing laboratory, such as UL or Intertech, it really doesn't matter what type you use. In this case, I found a couple name brand UL listed ends that actually have lights in them that light up when they are energized. Here's another style right here that does not have a light in it. These are nice heavy duty extension cord ends. They work great. Here's another style, and they make all of these in both the plug and receptacle ends. So to swap this cord end out, you're gonna need a good wire strippers and a screwdriver. That should be it. And we'll start by cutting the old end off. Obviously, make sure the extension cord is unplugged before you do this. And we'll just go ahead and chop it right off. And we can see the conductors inside are still nice shiny copper, so we know we have not overloaded this extension cord. If you cut this open and you see that the conductors are blackened, chances are you've overloaded the extension cord and they are not worth repairing when the conductors are black. And now we'll go ahead and open up our new receptacle end. And these just pop apart like so. A common issue I see with extension cord repair is people forget to put the shell on the extension cord first. We want to make sure this goes on the extension cord first before terminating the wires on the new end, because once this is terminated, there's no way to get your shell on the cable. So then you have to take all your connections back apart, slide this on, and then put the end back on. So here's what we're going to do. Before we do any work, I'm going to go ahead and loosen up the clamp on the back side here and slide this over the cord. That way we don't forget and we don't have to come back and redo this. Next thing we need to do is strip out approximately an inch of the outside coating on the cord itself. So what I like to do is score the outside of the insulation with my wire strippers, and I'll do that simply by putting it inside the cutters like so, and I'm gonna put just a little bit of squeezing pressure, not much, just enough that I'm gonna score it, not actually cut it. Remember, we do not want to cut the actual insulation of the individual conductors inside this cord. So I'm just going to bend this outside piece back and forth a few times until we expose our internal conductors. And there we go. There is our exposed conductors, and now we can terminate them on our new cord end. On the cord end, all of the terminals are actually color coded. So this silver colored screw is going to be the neutral, this white wire. This green terminal is going to be ground, which is going to land on our green wire. And this gold colored screw is going to land on our hot. Some replacement cord ends will have a strip gauge listed on the back side here. This one does not have that, so I'm actually going to have to eyeball this one. And basically, we're just going to need enough stripped out to be completely under the terminal screw on the receptacle. So I'm gonna say that's about 3/8 of an inch. So we're gonna need to strip 3/8 of an inch out on each one of these individual conductors. So using our wire strippers here, we can simply strip those out. And there we go, those are ready to be installed on the receptacle end. Because these wires have to fit between the terminal screw and the back side of the housing here, I'm gonna actually go ahead and put a pre-twist on each one of these stranded wires so they are bundled together neatly and none of the individual strands will poke out as we push it into the actual termination on the receptacle. So I'm gonna start with this green screw here. So if I roll this over and give it a tap, notice how that little square washer on the green screw fell open. We want to make sure our wire is sandwiched between that washer and the back plate within the termination. So if I roll this back over, you'll see that little flat washer will fall back down. I'm gonna give it a tap there, and there it just fell down. So we do not want to put our wire between the screw and that washer. We want to make sure that it's sandwiched between the washer and the back plate. So it's usually nice to let gravity help pull those down. So I'm gonna actually take advantage of that and push this ground wire in. And there's what that looks like. We should have a tiny bit of copper still exposed. We wanna make sure there is no insulation inside the termination. And I'm not sure if you're gonna be able to see it on camera, but there is a small gap right there and you can actually barely see the tip of some of the strands of wire on that side of the termination. So we know that this ground wire that we just pushed into this terminal is seated all the way, and now we can go ahead and tighten this screw down. And with that, the ground connection is complete. And now we can do the same for the neutral, but notice the neutral connection is actually closed. So we're gonna have to go ahead and open that up. And again, notice only the screw came out. That little washer in there did not. So I'm gonna rotate this and give it a little tap. There we go. See that little bracket or square washer popped open? Now we've got a place to sandwich that neutral wire in. With that open, I am going to slide the neutral wire in, taking care so that none of those strands actually pop out. And again, we can see that there is copper exposed on this side of the termination, but not so far back that we're beyond the back side of the receptacle. We do not want exposed copper way back here. Just enough that we know there's no insulation within that termination. Also, we can see on the right side here that we can see the tip of that wire is past the termination. So we know that this wire is completely within the termination, and now we can tighten this neutral down. There we go, great. Now all we have left is the hot terminal, and same thing, if we take a look on the back side here, notice that hot termination is closed, so we're gonna go ahead and open that up. Same thing, we gotta make sure that little square washer is open, so I'm just gonna tap this and let gravity pull it down. Now with that opening available to us, we can go ahead and bend our wire around and poke it in. See what happened here? Notice how these wires started to fray and bend out. That means it started rubbing on the termination connection before it was completely inserted. So I'm gonna go ahead, pull it back out, and I am just going to retwist that. We don't want to see those wires uncoiling. We want to see those wires completely straight within that connection. So we'll try poking it in there again, this time to make sure that none of those wires rub on the screw or on the side of the termination. And there we go. No wires are frayed out on us, and the wire is going all the way through the termination. We can go ahead and tighten this screw down. And that's it for terminations. Now we can go ahead and put our shell onto the actual receptacle piece itself. These are usually clocked somehow, so that means there is an orientation of how they fit together. Typically, when you look at the actual receptacle end, there will be some sort of keyway, and that's exactly what this little bump right here is. So this little bump is actually going to correlate with a corresponding indentation on the actual shell. So this piece of the shell actually needs to be oriented to fit this piece on the receptacle. So I will rotate that and now it will fit together nicely. Now these screws can be a little tricky getting into that shell. You have to push a little hard to get them started, and you have to be spinning while you are pushing. These screws are actually a really coarse thread. Notice how those are actually really steep and they don't look like a regular screw. So it takes quite a bit of force to actually push those in. So be very careful the screwdriver doesn't slip and poke you. So we can twist all of these screws in now. Again, make sure the screwdriver doesn't slip and stab your hand. Great, there we go. We're not quite done yet though, because we actually have to clamp this back piece down as a strain relief on the cord. Otherwise, our cord, if it gets pulled, it's actually gonna be pulling on the terminations inside the plug here, and we don't want that. So we're just gonna go ahead and tighten this clamp down in the back, which will grip the cord and make sure that any pulling happens on the outside of the cord and not the individual conductors inside the cord. You don't need to go hog wild tightening these down. You don't want to pinch the wire so hard that it internally breaks something, but you want to make sure it is tight enough, and you will see your cord flatten out a little bit. And there we go, a nice solid connection, and this extension cord is repaired. Anytime we do a repair like this, we want to double check our work. I just plugged this cord in, and it looks like the light inside the end is lit up, so that's a good sign. But let's double check it with a receptacle tester just to make sure we got the hot and the neutral in the correct orientation. And we're plugged in here, and on this particular model, 2 oranges and no red means we are good to go. So let's also replace the block heater end. Now this is going to be a little bit different because notice this cord is actually flat. So let's start by cutting off the end. I'm actually going to cut back just a little bit because I do know this cord was overheating a little bit at this end. So I'm going to cut back just a few inches so I know I've got good copper in this cord. This cord is plenty long enough, and I can afford to lose a few inches on this cord here. So the first thing I'm going to do is inspect these wires and make sure they're even worth repairing. And I see nice shiny copper there. They don't look all black. They don't look all burnt up. The insulation around that green wire is still fine. These outside wires do not have extra insulation around them, just that ground wire. So it looks like we are in good shape here, and we should be able to repair this. In order to hopefully prevent this from happening again in the future, I'm going to go ahead and put a cap on this cord. That way when this block heater is not in use, I'll be able to put this cap on to hopefully reduce some of that corrosion in the future. So first things first, I'm going to slide my cover on. And that one I'm going to slide way up so it's out of the way. Then, just like with the other end of the receptacle, we can go ahead and unscrew these 3 screws in the front and separate the actual cord end from the shell. And then we can go ahead and slide the cord through the shell. Remember, don't forget to install the shell first. The first couple times I did extension cords, I forgot the shell and had to take the cord back apart so I could slide the shell on. Great, now we're ready to start stripping these wires out and land them on the plug end. But I'm sure you've noticed a problem. How do we know which one of these is hot and which one of them is neutral? The ground is obvious. The ground has a green insulation around it, right? But these other 2 do not. So how do we know which one's hot? How do we know which one's neutral? Now, some will argue that it doesn't matter in this case, and honestly, they're 100% right. On an application like this, both of the wires, the hot and the neutral, both just go to a heating element inside this red tube here that does the heating. That heating element doesn't care which one's hot and which one's neutral. However, on flat cord like this, there actually is a way to tell which one's hot and which one's neutral. I am going to do my best to show this. It might not show up very well on camera. Look at this conductor right here closest to the camera. Notice if I rotate it, there is a nice radius to this particular conductor. But if I flip this over and we look at this other cord, notice how this one actually kind of has a flat spot on it. Maybe even holding it like this makes that a little bit clearer. Yeah, if we look at the cord like this, we can definitely tell that this side is more flat and this side is more rounded. The flat side is neutral and the rounded side is hot. So that's exactly how I'm going to land it on the end here. This flat side conductor is going to be neutral. The green is, well, obviously going to go to the ground. And then the hot, this rounded side, is going to go to the hot end on this plug. The next question is, how do we strip this out, right? I like to use a diagonal cutters and get in between the individual strands and just clip out about 1/4 of an inch. So this is all I've done, is I've separated them just a little bit. Now with them separated just a little bit, you can grab one of them and pull. And that's actually going to separate it out. Now this ground is going to pop out of the channel that is then made, and we can actually grab between the insulations here and pull those back as well. Now we've actually got separation here. We've got, in this case, this is our hot because it's nice and rounded on this side. And on this side, we can tell there's a flat spot running up the conductor, so this is our neutral. Now we've got our 3 individual conductors. Now I've separated these a little too far, so I'm gonna go ahead and cut them down to about 1 inch of separated conductors. Then we can go ahead and strip them out to about 3/8 of an inch and land them on our plug end. So I'm gonna cut these middle banana peels off. And looks like in my case I got to trim off about 1/2 of an inch just because, again, I stripped those out a little too far, demonstrating how to pull the conductors apart. And then each one of these conductors we are going to go ahead and strip out to about 3/8 of an inch. And there we go. Same thing on the receptacle. I'm going to pre-twist all of these stranded conductors. That way they slide into the holes on the plug end correctly. And there we go. These are ready for installation. Now, before I install the actual plug-in, I'm going to quadruple check that my shell is already installed. That way we don't get the plug-in installed and we realize we have to take it all back apart again to put this shell on. Just like with the receptacle end, there are little square washers behind the screws that we need to sandwich the wire in. So in this case, all of the screws are actually all the way out by the factory, so we don't need to unscrew anything. I can see all of the square washers are all the way out. This one's fell down a little bit, but we'll be able to fix that in just a minute. Way down here at the bottom, we have our ground screw, and I can see that opening is all ready for us. So let's go ahead and start by terminating the ground wire. Now these flat cords are a little tricky to use, definitely. We got the ground wire poked in. Notice we can see there is copper right before the termination. And again, it's gonna be hard to see on camera, but I can see down inside there that the tip of that conductor is beyond the termination just slightly. So we're gonna have good connection here, and I can go ahead and tighten this green screw down. Awesome. Now we can rotate it. Again, the gold colored screw is going to be hot, and the silver colored screw is going to be neutral. So I'm just gonna grab the next wire here that's convenient for me, and this one looks like it is the rounded over conductor. That means it is hot. So I'm just gonna land the hot right here on this hot terminal. I'm gonna roll this to the side and make sure that square washer opened all the way up for us. Again, make sure this pre-twist is good so when we insert the conductor, it doesn't fray on us. And we can go ahead and insert the wire into the connection. And this is really hard to see in person, let alone on camera, but this insulation ends right about here, and then I am able to see some conductor going into the termination, and I am able to see on the other side of the termination that the conductor is poking out as well. So I'm gonna go ahead and tighten this screw down. Again, I am going to double check by looking in there and making sure there is no insulation under the termination. And it looks like I can see just a sliver of copper there. Remember, we should not see copper sticking out the backside beyond the actual plug plastic here. If you do see copper coming out this far, you've stripped it out too far and you're going to need to redo your connection. That extra copper is just another failure point. So finally, what we've got left is this neutral wire. So I'm going to flip the plug over and let gravity open that square washer up again for us. Looks like it is open. I'm going to make sure our wire is twisted so it won't fray when we push it in. And then we can slide that wire in, making sure it seats all the way. And there we go. Again, just because of the way this particular plug is set up, it's going to be really difficult to see on camera, but you can see that black insulation goes through there. And I can see just a sliver of copper before the termination. So I'm going to go ahead and tighten this screw up. So now with our terminations made, we can go ahead and install the shell. Just like with the plug, there's going to be a little keyway on the actual end, and there's going to be a little keyway on the actual shell. Those need to fit together. If we had this twisted around, the shell's not going to fit onto the plug end correctly. So we need to make sure we line up those keyways. In this case, I happen to have it on the cord the correct way, but otherwise you could loosen these up and flip it around, no problem. So let's go ahead and tighten these front screws down. Same thing, these are those really steep threads, so you got to make sure you've got enough force and you're twisting it hard enough that it's actually going to run that screw in. Just be careful you don't slip and stab your finger. Been there, done that. These screws are intentionally difficult to install. That way they stay installed once they are in. And there we go. This front piece is done, but again, we're not finished. We have to actually tighten down this strain relief so if this cord gets pulled on or yanked, it's not putting that force on the actual terminations, it's putting that force directly on the cord, which is going to be able to handle it a lot better. Now, fortunately, in this case, this cord, once I tighten these clamps down, these clamps will grab onto this cord. So there won't be any slop on this cord once we tighten it down. If you've got a cord end that is not able to grip on your extension cord, you actually need to find a different end that's going to be able to grip better. They make cord ends that actually have adjustable grippers inside this back piece here for different size wires. Now, I will say in a pinch, you could build this up with some sort of vinyl electrical tape or heat shrink or something like that, but that gets to be a little bit of a gray zone as to whether or not that's acceptable. In this case though, we're gonna be okay by pinching down this strain relief, so let's get this tightened up. And in this case, this strain relief is gonna pretty much close the whole way. A nice solid connection on our plug end. And I've got a cap that's going to be able to protect this connection when not in use. And let's check the actual cord that we just fixed with the actual block heater that it's going to be used with. And there we go. It looks like it's working. I can hear the coolant inside there boiling. I thought there was supposed to be an indicator light on this plug end, but maybe not. Maybe I misinterpreted when I blindly just quickly bought it. But yeah, as long as this one's got it, we're good to go. Hopefully I won't need to move any more snow this year, but this cord and that block heater are now ready for next season. It's a great feeling to fix something yourself, but you need to recognize when a cord is not worth fixing, or even safe to fix. You should never fix an extension cord that has actually been overloaded. Here's a piece of extension cord that I've intentionally overloaded. You can tell by the ends that the wire got pretty crispy. Notice how this copper right here actually has more of a grayish tint to it. That is signs of being overloaded. So on the ends here, it's pretty obvious that this cord is no good. But if you were to just grab this cord and look at it in the middle, it doesn't look that bad, right? So let's cut it open real quick and see what the condition of the conductors are. And in this case, I'm not worried about wrecking anything by stripping it out too hard. I am noticing for sure that these conductors feel a lot stiffer. They don't feel as flexible as they did before. They do have a slight discoloration to them, which is going to be a little difficult for you guys to see on camera. I didn't overload the ground wire. I only loaded the neutral and the hot. Yeah, I mean, you can at least see that on camera. Look, there is a color difference between the copper in this neutral and the copper in this ground wire. But yeah, I mean, look at the color difference between the two. This is a lot healthier looking copper. This looks like it's got like a grayish tint to it. These wires have been overloaded. This extension cord would have been trashed if we'd have cut into it and noticed that color difference. For argument's sake, here is a piece of that same extension cord before it was melted. It's actually brand new off of a spool. So this is where I got it from. It's brand new copper. That's exactly where I got that from as well. So let's open this up and see that there is no color difference. And again, I'm not taking care to strip these out properly this time. But look at this. There is no color difference between these conductors. Same exact cord as this right here. And look at the color difference between this hot and neutral on this cord. Remember, these are the ones that got overloaded. And look at the difference on the same exact cord from the same exact spool. So if you've got an overloaded cord and you notice that color difference, that cord is trash. Throw it away. Another common issue is a cord like this. This cord was used in a machine shop and was exposed to oil. And notice if we bend it, the jacket just crumbles. If you see an extension cord with a crusty jacket like this that just shatters, it's not worth saving. And here is another issue. This cord on the outside feels just fine. The cord itself looks just fine. I'm gonna get my microphone right up to this and watch what happens when I bend this. That crispiness is actually the inside insulation that has been degraded. The outside insulation is still just fine. I don't even know if I'm gonna be able to strip this out. These individual insulations just shatter when they are bent. If you've got a cord like this, it is also not worth saving. Throw it away. Before repairing an extension cord, always check along the full length of the cord. If you see any nicks or chunks taken out of the outer jacket, or see exposed conductors, the cord is not worth saving. Wrapping electrical tape around the issue is not a good fix and will only hide the fact that the cord has been compromised. Fixing extension cord ends can be a great way to prolong the life of a cord that is in otherwise perfectly usable condition. Just remember to get ends that are rated for the cord's amperage and are listed by a nationally recognized testing laboratory, such as UL or Intertech. If you made it this far in the video, consider liking and leaving a comment, even a subscription if I've earned it. I've just launched a Patreon as well. I'll be making these videos regardless, but any support there will open up new ways for me to present these videos. Thanks for watching. We'll see you on the next one. Bye.